Hello everyone. My name is Srihari K, and today I am proud to present the culmination of my internship journey, Slate. Slate is more than just a task manager, it's a high-end academic utility built on MERN stack. That aims to redefine the productivity through intentional minimalist design. As we move through this presentation, we will look on how modern web technologies can be leveraged to solve real-world student problems. So, talking about the WSA internship program, it is a premier technical training ground designed specifically to bridge the gap between traditional academic theory and the fast-paced world of industry. It's a level full stack development program. During this internship, the focus was not just on syntaxes, but on mastering the complete JavaScript ecosystem from the ES6 patterns to complete RESTful API designs. I work with professional grade tools like Git for version control and the followed agile methodologies to ensure that the production quality output was superior. This project represents my mastery over the complete MERN architecture from the initial database schema to the final user interface. So the student's dilemma, academic noise. So let's look at the problem. Information is fragmented across learning management systems, emails, messaging apps, the academic portals, etc. This creates a massive mental context of switching cost. Researchers suggest that after an interruption, it takes an average of 23 minutes to fully refocus on the task at the hand. When students have to check 5 different sources just to see what's due, they are just not losing time, they are losing their cognitive energy that should be spent on study. So, what's the solution? Slate is our solution. It is a centralized academic dashboard that consolidates every deadline into a single authority source. We didn't want to build another cultured app. We followed a less is more minimalist philosophy where every visual element has a functional purpose. Using glassmorphic aesthetics, we translucently and depth to create a visual hierarchy that guides the eye naturally to the most important tasks rather than stressing a core into satisfying the most meditative ones. So the project objective and success matrices are our primary goal was a 60% reduction in the time students spend on tracking assignments. To ensure this tool was robust, we utilized MongoDB Atlas for cloud-based data persistence, ensuring that data is safe across devices without failures. We also focused heavily on the user experience, implementing 60 FPS animations via frame of motion and a zero-cost configuration authentication system that using university roll numbers. This removes all friction, allowing a student to go from logging to task management in seconds. Next is functional and technical requirements. From a functional standpoint, Slate supports secure JWT-based authentication and full CRUD operations, allowing users to create, read, update, and delete assignments. Now, technically, the system is built on RESTful API architecture using standard HTTP verbs and JSON bodies. We prioritize responsive engineering, ensuring that whether a student is on mobile device or a 4K desktop, the layout adjusts seamlessly via CSS grid and Flexbox. We also build in comprehensive error handling to ensure that the app stays alive even during network timeouts. Yeah, implementing the CAP theory. So, why MERN technology? And that's a good question, I guess. Why MERN? The answer lies in the unified JavaScript ecosystem. So by using JavaScript from the database queries all the way to UI components, we eliminate the mental cost of switching between different languages like Python or PHP. The significant boost development velocity. Furthermore, MERN is a offer native JSON data flow. So React props without needing a heavy transformation layer was a huge advantage. It's a stack proven by giants like Netflix, Uber, and it's massive for scalability and performance. So yeah, hats off to that. Next is the MongoDB. At the base of our stack, as you all know, a MongoDB, a NoSQL document-based oriented database system. Unlike traditional databases that require rigid schema, MongoDB allowed us to be agile, Like we add fields without complex migration. We use the bson format, which is a binary extension of json, and it supports data types like dates, object IDs. So it was an easy move. So when MongoDB retrieves a document, it's already a native JavaScript object instead of those queries of traditional SQLs. So yeah, now the Express.js, so the backend framework. So moving up the server layer, we have Express.js as usual. It's a minimalist, unopinionated framework. It doesn't force a specific structure on the developer, which was a blessing for me. I implemented a modular middleware processing pipeline where every request passes through a chain of functions that handles by course and pass. So they then validate the JWT token. This allows for a clean separation of the concerns that make the backend highly maintainable as we scale. So next is the React JS. So the heart of our user interface. It's a component-based architecture allowing us to build reusable, self-contained units like our assignment cards, etc. So the real magic happens when the virtual DOM drifting algorithm occurs. When a user updates a task, the React computes the minimal set of DOM operations needed, so allowing us to maintain a high frame rate even in the complex UIs. So since Slate is not a single page application, transitions are instant, making the web app feels like a native desktop tool. So the Node.js, powering our Node.js, which is an event-driven non-blocking IO model, as you all know. It's critical while Node is waiting for a database query to return, it can continue to handle other incoming requests on its single thread event loop. So it runs on a Google V8 engine, which converts our JavaScript directly to optimize machine code at runtime. So it gives us performance rivaled by compiled languages like C++ while maintaining the JavaScript flexibility. So it was a blessing for me. Next, moving into our architecture, it's a three-tier architecture. At the top, we have the client layer. Then React SPF focused on the management class of UI in the middle of the server layer, or Express.js API that handles every lifting business logic and the JWT authentication. At the bottom is our database layer hosted with MongoDB Atlas. These layers communicate via HTTPS using axioms on the front end and the MongoDB backend. So yeah, this is a comparison of the traditional versus serverless architecture. During the design, we compared the traditional one with the serverless options like AWS Lambda. We chose a traditional approach for Slate to ensure that the consistent 1000 millisecond response time, while serverless can be cheaper at low volumes. The cold start latency of 1 to 5 seconds was a negative impact for me. Surely it would be a negative impact on the students as well. So by running a continuous express instance on the server, I managed to keep it warm and ready to process requests instantly. So moving on, we have the database schema design. Our schema design focuses on efficiency. The user collection stores hashed passwords and unique roll numbers for fast lookups. The assignment collection uses object IDs as foreign keys to reference the user. We purposefully did not embed assignment within the user to prevent document bloat. So a common pitfall in NoSQL. So next is the user flow diagram. The user journey is designed for zero friction. When a student natives to the app, the React frontend loads it instantly from the white dev servers in development servers. Because this is a demo environment, mock assignments are played to show the functionality immediately, as you see, as you will see in the demo. Next is the back end implementation. So our backend entry point is the server.ts. It initializes a middleware stack, including the CORS configuration to whitelist our front-end origin. So we used Express.json to pass the incoming request and a custom logging middleware to track the API traffic. A unique feature I added is a mock mode. If the MongoDB connection fails for any reason, the server automatically switches in the memory stage so that the demo remains functional during my presentation. In if I anyhow implement this, I would replace it with you know cap theory essentials. Next is a secure authentication implementation. So security is a paramount feature. We implemented JWT, JSON Web Tokens, for session management. Upon login, the server signs a token containing the user ID, which is then stored in the browser's local storage. So for password security, we never store plain text. We use bcrypt library with a 10 soltron to hash the passwords. So the controller logic, the logic is divided into specialized controllers. For example, our GT assignments controller queries the database and handles empty results on errors gradually or and gracefully. So returning data in under about 30 to 40 milliseconds. Output controller for the updates uses a special spread operator, so allowing us to update only specified fields like status or priority without rewriting the whole document, which reduces the bandwidth and also improves performance. So the middleware architecture, as I said, a middleware is the guardian of our roots. The middleware interception every request to protect the backend and the roots. So it extracts a bearer token from the header and verifies the JWT signature. If the token is invalid or missing, it returns a 401 unauthorized error back to the server. So we also have a global error handling middleware that catches the unhandled exceptions and prevents the server from crashing, which is common as you see in these task management apps. So React folder structure and organization, we are moving to our what is front end development. Organization is a key of professional code databases. We separated our concerns into clear directory: SRC components for UI, SRC hook for usable objects and logics, and SRC services for a API client layer built on axioms. So we use TypeScript interfaces to define our date shapes like the assignment and user types, which allows us the compiler to catch bugs at development time rather than the runtime. Next is the state management with React hooks. So we rely heavily on React hooks, use state managers, transients UI like model visibility, while using effect handles our side effects such as fetching assignments on the component mount. We also use the callbacks and use demos. Next is the API bridge. So the communication bridge, it's built with Axios. We created a custom instance with a 10-second timeout to prevent hanging requests. Most importantly, we implemented interceptors. The request interceptors automatically attach the JWT tokens to every outgoing call, and the response interceptor handles errors globally, logging them and returning them in the user-friendly messages. Then is the major challenges that I encountered. The early on I struggled with the CORS errors when connecting the React front end to the Express backend. I solved it by configuring a proper whitelist and a credential policy. Another hurdle was a prop drilling, which I resolved by creating a custom hook like user assignment to encapsulate the state. So we also dealt with infinite refresh cycles in authentication state. So that was a big of a dilemma. I couldn't find out why that happened, and eventually, yeah, Jimmy helped me. It's fixed by optimizing. It was fixed by optimizing how app checks the initial tokens. Um, Next is the key learnings. Yeah, obviously, internship has transformative. I moved from understanding individual languages to grasping the entire full stack architecture at a single go. So I mastered the RESTful design, component based thinking, and a professional Git workflow. So yeah, I also use how to use Chrome Dev tools and backend logging to isolate and solve complex problems. So what's the future scope and all? The future of Slate is even more exciting, I guess. I plan to integrate AI-powered prioritization models that analyze our workload and suggest which tasks to do first. I also want to implement a two-way sync with Google Calendar using an OAuth system. So your assignments are automatically shown up as calendar events. So we are also looking collaborative study features like AWS S3 integration for file attachments. So yeah, I hope Slate is a testament to what can be achieved when performance design and student needs are aligned. So I would also like to show a slide demo of how the app works. So as you can see, the I want to show you Slate in action. So I designed this demo to showcase the MERN stack handles the entire life cycle of an academic assignment from the moment it is assigned to completion. So this is my UI. As you can see, it's a bit of a glassmorphic design. So in a PC version, it's not that visible, but if I see, it shows a depth and a subtle glass design. That's what glassmorphic essentially means. So yeah, now clicking on the floating button, we see an add assignment task. So let's add a new assignment. Oh, what I say, AI? Yeah, why not AI? No, so it's the title, right? So let's say project report, and the subject, yeah, of course, AI. Sorry. So and I say it's the deadline. So deadline I keep it to 18 tomorrow. Or just say so. Oh, and I set the priority to high and it's in progress for me. So, and I created that thing. So when see close, really pay attention that when I click submit, the task appears on the dashboard instantly. So this is the optimistic UI pattern I talked about earlier. So we update the React state even before the API pattern confirms that, yeah, MongoDB at least has confirmed this. So this creates a zero latency field, making the web feels as responsive as native mobile apps. So yeah, here we have the priority filters, red, amber, and blue. So yeah, I intentionally went for green, but green since you, so I eventually changed it to blue. So yeah, blue means yeah, you have plenty full time. You just chill out, do it at your own time. Amber means yeah, it's close on. Keep an eye on this. Red means do it immediately. So that's it. So I think that's the end of my demo presentation. Oh, and also when I complete this, so the it shows that I have completed the 100% progress. And for a class monitor or a class rep or teacher's view, you can see the total student finishing level also. Next are the stats. Here we can see my stat performance review. What's the completion? What were the total assignments? Pending ones, progress, completed ones, etc. So yeah, that was my what do you say demo presentation also. Uh, Also, the full source code is available on my GitHub. I'll provide the link in the presentation. I want to thank you, the WSM internship team, for their guidance. And now I am open for your questions and discussions. Thank you for your time. Thank you.